All right, let's look at the inverse trig functions. All right, so here's the definition of inverse function of sine function, which is called the arc sine. Right. So arc sine, you can actually write the arc sine, but the typical notation is sine inverse of x is equal to y if and only if, right? So remember, it's just an inverse function. So if the original function goes from x to y, and the inverse function is going to go from y to x, so you just have to go backward, right? So here, if arc sine of x is equal to y, then the original function, so sine of y, sends it back to x. It's just a reverse process, right? And the problem with the sine and the other trig function is that they are typically not one-to-one functions. So they cannot really have inverse functions. So we have to do a little bit of tweaking so that the inverse functions can make sense. All right, so let's look at the picture of a sine function. So I'm going to open up a GeoGebra here. All right, so here's the sine function. All right. All right, sine curve, it just goes up and down like that. All right, so you can easily see that it's gonna fail the horizontal line test miserably, right? You have so many intersection points, so it fails the horizontal line test. So what we're going to do is we're going to actually chop off things that makes this not one-to-one. So we're going to only look at the section of it. So for example, all right, so I'm going to just get rid of this one. All right, so we're going to put a little bit of restriction on the domain. We're going to only consider between negative pi over 2 to positive pi over 2, right? And you draw a sine function, right? So this is only the portion, right? Kind of a middle portion of the sine curve, going from this is right here is negative pi over 2, and this is positive pi over 2. So we get this picture, right? Now, this particular piece passes the horizontal line test. So this is one-to-one, right? So we're gonna put the restriction here, and the restriction is we're gonna restrict ourselves the sine function from negative pi over 2 to positive pi over 2, right? Then you can see it in the picture, right? The range is going to be still negative 1 all the way to positive 1. So we have range of the original function is still negative 1 to positive 1, right? Then we know that what the inverse function look like, right? So you just have to reflect it about the 45-degree line. So let's look at the arc sine. So it's a sine. So it looks like this, right? So you can see the reflection. Maybe I should draw y equals x in there. All right, oops, sorry, I messed that up. Okay, all right, y equals x. All right, so this is, I don't like the way it looks. I'm gonna actually change this style a bit. I'm gonna turn it into maybe a dotted line or something here. All right. All right, so we got that. All right, so you can see the symmetry about the y equals x. So this is the original sine function with restriction on the domain, and reflected over to the other side, you can see that this is the graph of the green is the graph of arc sine. All right, so maybe I'll just pick out here. So this is the graph of arc sine. All right, let's take a picture of this. All right, so I'm going to just take a picture of this and throw it in here. All right, so here. All right, so that we can remember what it looks like. All right, and so you can see that the domain of arc sine would be the range of the original function. So it's going to be -1 to +1. All right, so you can see that it's going from here to there. So that's going to be the domain of the arc sine. All right, and the range is going to be the original restricted domain. So it's a -π/2 to +π/2. It might be hard to see because it doesn't really say π/2, but right here is a +π/2, and down here is -π/2. All right, you can see the negative sign. Actually, so yeah, see, it is the negative sign. All right, and we're going to have to do a similar treatment with the arc cosine and the arc tangent. So let's look at the picture of arc sine and arc tangent. So I'm going to just get rid of all this. All right, so I can keep that probably. All right, so here's the graph of cosine function. All right, again, it's going to fail the horizontal line test miserably, so it's not one-to-one. So in order to make it one-to-one, so this is what we're going to do. I'm going to actually only keep this portion from 0 to pi. All right, so let's do that. So if all right, so we want between 0 to pi, we're going to have a cosine function. All right, so this is what it looks like. Right, so it's just a piece of cosine function. All right, then this is one-to-one. So what we can do is we can reflect it so that we can find the arc sine. So arc cosine. So arc cosine looks like this, right? Then you can see the symmetry there, right? So I'm gonna actually just erase all the other ones, right? So this is what the arc cosine looks like, right? So I'm going to capture this. All right, so just take a picture of that. All right, then I'm gonna just throw it in here. All right, maybe I might have to make it a little bit smaller so that it fits. All right, so the restriction was we have to restrict the domain from 0 to pi. And the range is still -1 to +1, right? For arc cosine, you just have to flip it, just like before. So domain of arc cosine is -1 to +1, and the range of arc cosine is 0 to pi. Right? So you can see that here, -1 to +1, and here is pi, and obviously here is 0. All right. So that is the arc cosine. All right. All right. So let's look at the last one, arc tangent, for this video. All right. So arc tangent. So what does the tangent look like? All right. So I'm going to just get rid of all this. All right. So here is what it looks like. Tangent of x. All right, so tangent is a periodic function, and you have a whole bunch of these pieces, right? So obviously it fails the horizontal line test, so we only pick the middle piece. So we get rid of all the other pieces, right? So we're going to do this, right? So we're going to do, say, if we're going to pick the middle one, so it's going to be a pi/2 to pi/2, -pi/2 to +pi/2, and then look at the tangent graph. right? So we only pick the middle piece, right? Then we just have to reflect it to find the arctangent. So arctangent look like this, right? So you can see that there's a reflection, right? So arctangent looks like this, right? So maybe let's take a picture of this. All right, so I'm gonna just take it, it's a kind of long sideways, so maybe let's probably put it like that. All right, and then throw it in here. All right, I might have to make it a little bit smaller and then fit it there. Maybe I can be a little bit bigger. All right. All right, so the restriction was we're gonna actually have to pick the one piece. You have negative pi over 2 to positive pi over 2. And the range of the original tangent function is all real numbers. So it's going from all the way from negative infinity to positive infinity. Right? Then for the inverse tangent or arctangent, it's going to be just a flipped version. So its domain of the arctangent is from negative infinity to positive infinity. So you can see that the function is defined for all real numbers. And the range is going to be between negative pi over 2 to positive pi over 2. It might be hard to see, but here you have a sort of a horizontal asymptote here. All right, this is pi over 2. It actually never hits it, so that's why it's a parentheses, not including negative pi over 2 or positive pi over 2. All right, so here is negative pi over 2. All right, so that's what the arctangent looks like. All right. So these are the first three, arc inverse trig functions: arc sine, arc cosine, and arc tangent. All right, that's it. I hope that this was clear.